Welcome to Math 119, Chapter 1.8, where we talk about solving quadratic equations. So this is where your factoring is going to come into play. So make sure you have watched that factoring video from Chapter 1.3 in order to better grasp how to factor and make your life easier. So linear equations is what we did in Chapter 1.6, where we learned how to solve just your basic linear equations. So trying to solve for these x values. Now, quadratic equations have a degree of 2, so a second degree. So they have this type of structure that you're going to be seeing here. Now, notice that you'll also still have something across the other side. It might not always be 0, but our goal is to get it to be equal to 0. Now, solutions, you're going to be hearing me say solutions a lot of times or solve a lot of times. Solutions are the same things as your x-intercepts. So solutions, roots, zeros, x-intercepts, any of those words are going to be interchangeable. So pretty much, I want you to think of the solutions as your x-intercepts going forward, because we are going to be talking about graphing pretty quickly in chapter 3.3. So how many solutions does a linear equation have, right? How many x-intercepts does a linear equation have? Well, if we were to draw a very, very quick representation of a line, well, an x-intercept, right, no matter what orientation you have for your line, at most it can have is just one x-intercept. Now you could draw a different line where you have no x-intercept, and that's fine. This is at most 1. Now, what about a quadratic equation, right? So at most, how many solutions could there be for quadratics? Well, depending on the case, most likely, or at most it can have, if we just draw our parabola, are 2 solutions. So at most 2. Now this actually tells us right from the degree, so it can have at most 2, or it can have at most 1, but in some cases it might not have any at all, and in this other case you might only just have 1. So it really depends on the quadratic itself. Now quadratic equations have the form ax squared plus bx plus c is equal to 0. So that is the structure in which we want. And you'll notice that down below, it'll just say a, b, and c are real numbers, where a is not equal to 0. Now we talked about why a is not equal to 0 in, I want to say it was 1.3, because if it is 0, that whole first term goes to 0, and then you're left with a linear solution again. So that's why that particular part is there. So to find the solution of quadratic equations, we're going to be setting these equations equal to 0. We do this because when we're talking about solutions or your x-intercepts, to find your x-intercept, we set y equal to 0. Right? That is where these values lie. This is when y is equal to 0. X is some number, but y is 0. And again, over here, x is some number, y is 0, a number, and 0. So on one side, normally we have y equals, so this side is going to be 0. Now, some quadratic equations can be solved by factoring, and others use the basic property of real numbers. So first and foremost, we have the zero product property. This is just saying, in order for this part to be true, a times b is equal to 0, if and only if. Well, in order to get this 0 to appear, either a is equal to 0 to get 0 times b to be equal to 0, or b is equal to 0, so that when we multiply it by a, it's still equal to 0. So one of these two things has to be equal to 0. So this means that if we can factor the left-hand side of the quadratic or other equation, then we can solve it by setting each factor equal to 0 in turn. This method works only when we have the right-hand side of the equation equal to 0. So it doesn't really matter which side is set equal to 0, as long as one side is 0. So for example, let's get to example 1. Find all real solutions of the equation. So we have x squared plus 5x is equal to 24. So the first thing we want to do that we had just talked about, get one side equal to 0. And we want to be very strategic, right? Because we're talking about factoring here. Is it better to bring these two over to this side or this one over here? Well, in order to figure that out, we always want to look at your highest degree because it's hard to factor if your leading coefficient is negative. Well, if this one is already positive, your highest degree being 2, if it's positive already, we want to keep its position. So that means we're going to bring the 24 over. So let's go ahead and subtract 24 to the other side. To get x squared plus 5x minus 24 is now equal to 0. So first thing we want to do, set one side equal to 0 by moving terms. Okay, great, we did that. Now, next thing we have to do, have we seen something like this before? Well, absolutely. In chapter 1.3, we learned how to factor. So next thing we're going to do is factor. Now, if you're not factoring this in this class, there is something wrong. We should be constantly factoring at every single turn. If you see a polynomial, your game plan is to factor. So we're looking at factors of 24 that can get us to 5. So 3 and 8, if and only if your 8 is positive and your 3 is negative. This way, when we add them together, so negative 3 plus 8, that keeps it a positive 5. But when we multiply it, we then get a negative 24. So that works. That is exactly what we have here. Now, if you don't know how to factor, please go back one more time to chapter 1.3. So now, because this is simple factoring, we have x minus 3 and then x plus 8 is equal to 0. So now this is where the zero product property comes in handy. So we're saying, okay, well, this can be A and this can be B. So that means we can say A is equal to 0 or B is equal to 0. So in this case, think about this as being your A and this as being your B. So x minus 3, and even if you wanted, you could bring the parentheses if you wanted. It doesn't quite matter. But really, you're just setting it equal to 0 and solving. So bring that 3 over. Bring that 8 over. So you're now with x is equal to 3 and x is equal to negative 8. Now, these are your solutions. These are your x-intercepts. Okay. So now let's have you try it again. So let's take a look at this next one. If you're ready, please pause the video and try this out on your own. Now, if we already have something set equal to 0 on one side, that just means it's less work for us. This is wonderful. So now we're trying to factor, right? Factoring is best. So how can we factor something like this? Well, we're going to be looking for a GCF. So GCF, what is your GCF? What should be a 5 and 1x? And it gets left behind. X plus 2 is equal to 0. So now, just like we did last time, this is A is equal to that, and this one is your B. So we're setting your GCF equal to 0 as well. So 5x is equal to 0, and x plus 2 also is equal to 0. So what does that mean for your solutions, your x-intercepts? Well, in order for your GCF to be true, x has to be equal to 0. So x is equal to 0 over here, and then x is equal to -2 over on the other side. Again, do not forget your GCFs matter. Well, I should say your variable of your GCF matters. So if you just took out a 5 and we didn't have an x in common, you don't have to set 5 equal to 0. It's only if you pulled out a variable when you factored. Set equal to 0. Okay. Now what do we have here? Well, there's a couple different things that you can do to get started. So if our first thing that we want to do is to get one side equal to 0, let's do that before we get worried about your fractions. So first, let's set one side equal to 0. So which side it would be a little bit better? Well, let's try and bring this fraction over to the other side. So we have x squared plus 5 over 2x minus 3 over 2 is equal to 0. So now how can we get rid of this fraction? Because we don't want to factor with fractions. That kind of makes our life a little hard. Well, what we can do, right, is try to get this one, well, two things we could do. We could try and get this into the same fraction. So to have a common denominator, we can multiply it by 2 and then kind of ignore all of your variables, or not your variables, your denominators. Or even better, what we can do to get rid of your fraction, we can actually multiply it throughout your entire equation. So even if this was a 3, slowly multiply your first fraction, your denominator out by multiplying it. And then once that one's gone, then you can tackle the next one. Then you can multiply everything by 3 to get it out. Or you come up with a GC, or not a GCF, an LCD. So if we do multiply everything by 2, that cancels, and we're left with 2x squared plus 5x minus 3 is equal to 0. Now you can go ahead and factor. So pause the video if that's what you needed to try and solve. All right, this one we have a complex factoring. So we're going to be using the AC method, or if you know how to do that slide and divide or any other method, please just go slowly, especially if you're doing slide and divide. Do not forget to divide. So you have 2 times 3, a -3, is equal to -6. Factors of -6 that can get us to a +5, but keep our negative, will be a +6 and a -1. This way we can have a +5. And when we go to multiply them back together, we still get back to a -6. I don't know why I put 5 there. There we go. So now we get to rewrite what our factors are. So we just used a -1 and a +6 to rewrite your 5. -1x plus a 6x minus 3 is equal to 0. Then we can go ahead and factor by grouping. So we're pulling out an x, 2x minus 1, keeping that placeholder, and then taking out a 3, even better, a +3. Now, as long as your parentheses matched, you did it correctly. So now we have x plus 3 and 2x minus 1 is equal to 0. So from here, we're now setting both of your parentheses equal to 0. So x is equal to -3. And to solve this linear one, we want to add 1 to the other side and then divide by 2. So x is equal to you have two solutions here. You have x is equal to -3 and x is equal to 1/2. Now on the next page, we're talking about solving a simple quadratic equations. So the ones that we've been working with so far have had the form ax squared plus bx plus c is equal to 0. In other words, they've had three terms all in a row. So it's nice and fully expanded. So now, what if we don't have that structure? What if we have something that looks like x squared is equal to c? Well, in which case, what we can do, if it is in this structure, or maybe it's something close to it, let's say it's minus c, right? We can add c to the other side in most cases. Other cases, we might be able to solve it pretty quickly first before doing that, but you can always give it a shot, right? But in order to get rid of your x, because your x is all alone to one side, which is awesome, right? But in order to get rid of your square, what do you have to do? Well, to undo a square, you get to square root it. Now, when you do square root one side, you do it to the other, but even more, you actually have to account for something. You have to account for a plus or minus sign, and we'll talk about why that is. The other one being a negative. The reason why is that your quadratic can have, not that it has always, but it can have two solutions. So you can have two solutions. Most. Again, this is any sort of quadratic model. However, when you square root, and we don't know what, or you might not know what a square root graph looks like, but they usually take on this shape where you only have how many x-intercepts? We only have one x-intercept or one solution at most. So what you did is going from one form to another is that you lost one of your x-intercepts or your solutions along the way. So you need to account for the double solution by adding that plus or minus sign. So a good rule of thumb, when creating your own square root, you need to add a plus or minus sign to the square root. So with that in mind, can you give A, B, and C a shot, or maybe just A shot? So here you have x squared is equal to 5. So it's already in that form before. Let's say it wasn't. Let's say this was x squared minus 5 is equal to 0. Let's say it's this variation. Well, first thing you want to do, well, we can't just square root everything and call it a day, right? We have that minus 5. So you really want that structure of x squared is equal to c. So that's why in this case, they added the 5 to the other side, so that we can do that value, that square root symbol. So we can take the square root of both sides, and do not forget to account for the plus minus sign. So that drops your square on one side. So you're left with the plus or minus square root of 5. Now, I'm okay if you leave it like this on a test. However, your homework might want you to show that there are 5 solutions. So one being a negative square root of 5, and the other one being a positive square root of 5. Now, another thing we can do, another technique we can do, so this still kind of has that form of x squared is equal to c. Again, if this was x minus 4 squared minus 5 is equal to 0, try to get the 5 to the other side before tackling this method. Now, if you asked me, oh, I know it's a square, so can I write 2 of them and then FOIL it out and then factor? Absolutely. Don't forget to bring that 5 over, but it's time consuming. And sometimes students make the error of, oh, I forgot that this is 5 and not a 0. So make sure if you do that, you bring the 5 over. So instead, if we want to be more efficient, if it is in this form here, right, all alone to one side, there's nothing else over on the squared side, we can go ahead and square root it. Do not forget to add the plus or minus sign. So now you get x minus 4 is equal to plus or minus the square root of 5. Now the last thing to do is to get your x value alone. So x is equal to 4 plus or minus the square root of 5. We cannot add the 4 into the 5 and make square root of 9 and then 3. That's not how it works, right? Square root of 5 is in fact a number. So again, your homework might need you to separate it out. We can say this is really x is equal to 4 plus square root of 5. And again, x is equal to 4 minus square root of 5. And I'm just going to write a little tidbit. Bring all non-terms to one side. What I mean by that is if this 5 was over here, or if you have some coefficient out front, bring them over to the other side before you go ahead and square it. Otherwise, you're going to be left with another term that's squared from your properties of chapter 1.2. So let's try it again on C. So pause the video, see what you can come up with. Okay, so the 8 is already over to one side. We don't have any sort of coefficient that we have to worry about. So we're going to go ahead and take the square root. Do not forget the plus or minus sign. We have 2x plus 3 is now equal to plus or minus the square root of 8. Now, talking about chapter 1.2, what did we know about the square root of 8? How can we simplify? Well, the square root of 8 is really 4 times 2, and they're both under a square root, which we know the square root of 4 is 2 root 2. Now we have that plus or minus sign to account for. So this plus or minus sign is going to go in front of our 2 on the outside. So we really have 2x plus 3 is equal to plus or minus 2 root 2. And now we can start to solve for your x. So bringing over your 3. Negative 3 plus or minus 2 root 2. Again, we cannot add and subtract 2 and 3 because 2 root 2 is a number. So these have to be glued together. So they're glued together. Then we can go ahead and divide by 2. And no, these 2's do not cancel unless you would be willing to break the terms up like this, in which case these 2's would cancel. Okay, I would accept either answer. It doesn't matter which one you do for me. I just think this one's a little bit easier to write out just more quickly. So these are the different ways that we can go about solving. Now, what if we come into contact when we try either one of these methods, or if we try to factor and it doesn't work and we know how to factor, right? So one thing we can do is the quadratic formula. Now we can use the quadratic formula when the polynomial is not factorable. So if it's not factorable, your mind should go right into the quadratic formula. Now you can use it at any point in time though. So even if it is factorable, you can use a quadratic formula. Now be very, very careful on the test for me. I would like you to factor as much as possible. So if you'll notice that in the directions, it says solve by factoring, I'm looking for factoring. So if you give me a quadratic formula when you go to solve for a problem like that, I'm going to be taking off just all but 1 point. Okay, so I'll give you 1 point for getting the solution, but that's not the desired method, especially if it's been labeled in the directions. So now the quadratic formula, we have again your structure of ax squared plus bx plus c is equal to 0. Now, we're trying to figure out what the quadratic formula is. So if you've seen it before, please pause the video, write it out, and test yourself on that memorization. So you have x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So how'd you do? Now you might be like, oh, where are these A, B's, and C's coming from? Well, these are actually coming from directly above from your formula. So you have B here, you have A here, and you have C from right here. So using your quadratic equation to come up with this formula. Now, if you're ever curious as to how to create your quadratic formula from something like this, you can actually use which I don't teach anymore, you can use completing the square in order to derive this quadratic formula. Now, before we get started with the quadratic formula and an example, let's take a look at what it means to be a discriminant. So the purpose of the discriminant is it tells us, or it determines, the types of solutions or x-intercepts, think about solutions being your x-intercepts, that are possible. Now, the reason why that is important and what it is, the discriminant, is b squared minus 4ac. Now, have you seen that very, very recently? Absolutely. It is actually a part of your quadratic equation, or sorry, quadratic formula. The reason why it determines your types of solutions is that there is a square root sign, right? And it's underneath the square root. So we're going to be very, very picky about the values under a square root. Now notice that I did not include the square root sign. So if I do ask you for the test or a quiz, what is the discriminant? Please, please, please do not fall in the trap where you've done all of the work and then you take the square root of that number. Do not do that. It is just without the square root. So how can you tell using the discriminant what type of solution you have? Well, there are 3 types of solutions. So graphical solutions, actually, let's do graphical solutions first. Well, graphically, right, we said how many at most x-intercepts can your quadratic solution or quadratic have? Well, at most, so I'm going to draw one more. At most we can have is 2, right? We've been kind of talking about that from the beginning of class. So depending on how we draw it either up or down, we can have at most 2 solutions, 2 x-intercepts. So 2 x-intercepts, 2 solutions. Now, another variation, right? Well, what if instead of 2, what if we can just have 1 x-intercept? So however you draw it, perhaps you only have 1 x-intercept. Or solution. I want to actually change the verbiage that I'm using. I want to say 2 real solutions or 1 real solution. Because what's coming up next, right? You go from 2 real to 1 real, and now you can actually have a variation. Well, what if your graph doesn't touch the x-axis? Something like this, right? Well, we have no real solution, no real x-intercept. So no x-intercept. However, we can use something called imaginary numbers. Now, unfortunately, we don't get to deep dive into imaginary numbers. So we're going to just very, very quickly on our next page, explain what an imaginary number is in its very watered down sense. So your imaginary solution just comes from just saying, okay, well, if it were possible that this x-intercept was up here, what would your solutions be? So we would have two imaginary solutions. Now, where is the two solutions or one solutions coming from, right? Well, these two solutions are coming from this plus or minus sign, right? So plus or minus, we said, okay, can give you two solutions, right? Whereas the one solution, we're going to take a look at why it's only one in a moment. So using your discriminant, we said your discriminant is b squared minus 4ac. Well, what happens if underneath the square root, right? What values can go under the square root? Well, let's say we can be greater than 0. Well, the square root of 4, right? That's okay, right? It'll still give you two real solutions. Two coming from the plus or minus. It's greater than 0, so it's going to be a real solution. Now let's say we take your discriminant and we now negate it. Let's just say it's less than 0. Well, what variation do you have? So if you have two reals, right, the opposite would be two imaginary, non-real solutions. Two imaginary solutions, right? So less than 0 means a negative underneath the square root. Are you allowed a negative under the square root? No, right? Not allowed. So now let's take a look at one last variation, right? Well, what is left? We said greater than 0, we have less than 0, and we're now equal to 0. Right? Well, if we're equal to 0, right, one solution, that's coming from, well, if we're the square root of 0 is what? Well, it's equal to 0. So that just means this whole thing, the plus or minus sign is gone, and we're left with whatever we have here, negative b over 2a. So that is where the one solution or one real solution is coming from. And the reason why we're not allowed negatives under that square root sign, again, is because in its most basic parent function, you'll notice that there are no negative x values on its graph. So that's why we kind of keep harping about no negatives underneath a square. So let's actually, before I go over here, let's determine how many solutions this might have just by using your discriminant. Well, we have a x squared plus bx plus c is equal to 0. So a is equal to 1, b is equal to 6, and c is equal to 13. So if we're looking at putting it back into this equation, right, we have 6 squared minus 4 times 1 times 13, right? So then you would just have to do the math pretty quickly, right? 6 squared, 36, minus 4 times 13 is 52. So are you going to have a negative or a positive underneath the square root, or a 0? Well, this will provide you with a negative, right? Negative 16. So if that's less than 0, we have two imaginary solutions. So just by looking at your discriminant, we can determine what type of graph we might have. All right, so now let's go ahead and use your quadratic formula in order to find some solutions. So let's go ahead, and if you're ready for it, just pause the video. Think about what we did from our at the very beginning about talking about solving. So first we want to see, is it factorable? And then we want to see, okay, well, If it's not factorable, let's use the quadratic formula. You'll notice here that we have a 1 on the other side. Now, typically what we want to do is bring we want to set one side equal to 0. So we're going to get 8x squared minus 4x minus 1 is equal to 0. So before getting started, set equal to 0. Set equal 0. Then you can try and see, okay, well, is it factorable? Unfortunately, no. So instead, what we're going to have to do is that quadratic formula. Now, you don't have to list out your ABCs. I tend to like listing out the ABCs kind of just to help us with your quadratic formula. And I'm also going to rewrite it here. Copy. There we go. So now we have negative 4 plus or minus the square root of negative 4 squared, use parentheses as much as possible, times negative 1. You'll notice that this negative 4 is not referencing that negative 4 over 2 times, oh, it's a positive 8, isn't it? Yeah. Okay, just watch out for all of the negatives. So negative times a negative 4 is a positive 4, plus or minus the square root of 16 plus 32 all over 16. So now we can go ahead and add what's underneath your square root. Now, just by looking at your discriminant, are we going to have 2 real, 1 real, or 2 imaginary solutions? Well, 48 being a positive number underneath the square root, you're going to have 2 real solutions. Now let's go ahead and simplify this 48. So the square root of 48 can be written or simplified as what? Well, your biggest perfect square in 48 is 16. So 16 times what? 3. So keep in mind, you can always create a factor tree. 2 times 24, 3 times 16, 4 times 12, and 6 times 8. If you don't pick the biggest perfect square, so let's say you picked 4, just keep in mind 12 has a 4 and a 3. So 12 still has a 4 and a 4 to make 16. So it still has more perfect squares in it. So that's why the biggest perfect square is better. So then you're left with 4 root 3. So let's go ahead and add that over here. We have 4 plus or minus 4 square root of 3 over 16. Now, are we done? Can it be any simpler? Well, we actually can simplify it a little bit more because 16 has something in common with the 4 over here and the 4 on the outside. Now, if it was only just one of these, you could either decide to break it up like this and then simplify, or you can just leave it. So in our case, we should have 1 plus or minus the square root of 3 over 4. And that could be your final answer. Now, again, your homework might want you to break it up into 2 separate solutions. Okay, let's try it again with B. Now, a lot of students won't take the time to do this first step, but sometimes they end up getting points off because they made such a silly mistake or a silly decision. Notice that we do not have the proper notation. So let's go ahead and rearrange it so that your terms are in descending order. And that way, when you go to do your ABCs or put it into your quadratic formula, you're not actually swapping your values. It happens more often than you think. Okay, so let's go ahead and put these values in. All right, just by looking at your discriminant, are we going to have two real, two imaginary, or one real? We're going to have two imaginary. Now, in order to figure out, okay, well, how do we overcome this negative under the square root? We need to figure out what an imaginary solution is. So how to tackle it. So all we're going to do very surface level with imaginary. Anytime you see a negative underneath the square root, you're going to take it out and call it I. The reason for that is that I is equal to the square root of -1. So you can break up this 16 or this -16 as -1 and the square root of 16. This way you can call this square root of -1 I and then go about simplifying. This would be then 4I. So we can put that over here. And again, that is all we are going to be doing with your imaginary numbers is you're just looking that it's negative, it's -1. You're going to take it out, call it I, and then keep going. All right, your last thing to do is to simplify. We should have -3 plus or minus 2I. All right, last one is C. So if you haven't paused the video yet, please do so now. All right, we still have is equal to 4, so we want to set it equal to 0 by moving over the 4. And then we can do your ABCs, 3, -11, and -4. So you have it equal to -11 plus or minus the square root of -11 squared minus 4 times 3, -4, all over 2A. Let's see, 14 times 3, 48 over 6. All right, by looking at your discriminant, what kind of solutions are we going to work with? Well, we will be having two real solutions. Now you do need to know some higher ordered roots. So make sure you know what the square root of 169 is. Now I would suggest go all the way up to 200 in order to feel most comfortable. Now your solution isn't just this, right? How do these answers compare from the other two? Well, one is an imaginary solution. The other one is kind of a little more complex with how the answers worked out. But this one, they're all whole numbers. So that just means x is equal to 11 plus 13 over 6. And x is equal to 11 minus 13 over 6. So start to simplify. 11 plus 13 is 24. Divided by 6, well, that's just 3. So x is equal to 3. And if we did it again, 11 minus 13, that's -2 over 6. That would be -1/3. So x is equal to -1/3. So if this happens, it just means that this one is actually factorable. So if you're going through and you're using the quadratic formula, if you notice that it comes out as nice whole numbers, it just means factoring would be a little bit easier. And I just realized I just said it was 3. It's really 4. Silly me. 24 over 6 is 4. Okay. Now let's use what we learned from the quadratic formula and figure out what we want to do with an application problem. So now stay till the end of the video. We'll talk about what happens if it's not in feet. I'll give you a little tidbit heads up for the metric system. Because your homework does do both. There was no way around it. On the test, I'll be using this variation though. So looking at this formula, and we can add something to it as well. We'll just do h of t, right? what I would like to do is figure out, well, what do these variables mean? Well, one thing we can do, this is V naught. What does V naught stand for? V naught stands for initial velocity. Because these are projectiles, so this specific one will have an initial velocity, and we can put that value here. Now, this object will be experiencing lots and lots of different velocities over its time in the air. However, this one is very specific as being the first or initial velocity. So then with that in mind, what do we think H naught would stand for? Well, H naught should be your initial height. Again, this object will be experiencing lots of different heights over the course of the time. However, this spot is reserved only for the initial height. Now, if H naught is not given, we want to assume that it's 0. And what do we think these T values stand for? Well, T will be some time. Now there's a few more. We have H of T over here. H of T. So we know H is standing for height and T stands for time. So this is the height after T. Now the last thing we want to take a look at is this -16. This -16, right? What goes up must come down is gravity. That is your gravity. So as you're going through your projectile problems should all have this formula or this structure. And if you're wondering for me, if I give it to you on a test, the answer is no, most likely. I also do not give you the quadratic formula, so that is another one you will have to memorize. So let's take a look at example 5. It says a baseball is thrown onto the field with a velocity of 60 feet per second from an initial height of 50 feet. When does the ball land? So figure out what are we given and what do we have to find? Well, your H naught, we said your velocity, it's your initial velocity. So we threw this ball 60 feet per second. And your initial height, right? How tall or how high was it to begin with? Well, this was 50 feet. So that means if we're trying to create some sort of equation, this -16 we said is gravity, so it's always going to be there. T squared plus 60t plus your 50 feet. So now what are we asked to find? Well, we are asked, well, when does the ball hit the ground? Let's see. So your graph, oops. Your graph looks something like this, where that was 50, right? We are looking for what? Well, looking for here. Now, what is that? Right? Well, this is, we don't know what T is. Do you know what H is here? Well, if this is the ground, H should be 0, right? So this being T, we're solving for T, we're trying to find your x-intercept, something that we did at the very, very beginning of class. So we have 0 for your height. And we have this formula. Now, the way that it's written here, right? We don't have a calculator in class. We don't have a calculator on the test or quiz. So do we want to use the quadratic formula right away? No. Do you want to factor right away? Or at least factor like normal factor? No. So let's try and see, is there something that we can make our life a little bit easier? Can you factor out a GCF? So look for a GCF. Now on a test, if you notice that your numbers are getting very, very big, that's not because I'm trying to be mean, it's because you should be thinking using some other skills first before you launch right into some of your techniques. So first off, right, all of these values have a 2 in common. And even better, your leading coefficient is negative, so let's take out a -2. So changing all of your signs, factoring out that negative. So you're left with this. Now, one thing we can do, because one side is equal to 0, we could divide out this -2 because we don't really need it. Not a necessary step, but sometimes it's nice just to work with what we've seen before. So now let's go ahead and use your factoring skills. Is it factorable? Unfortunately, no. But let's try and use your ABCs. You have 8, -30, and -25. Again, I'm trying to give you manageable numbers here. So you have x is equal to -30 plus or minus the square root of -30 squared minus 4 times 8 times -25 all over 2 times 8. And if you're thinking, oh my goodness, these numbers are large. Yes, they are large, but they are manageable. So we still have 30 plus or minus. If we don't know 30 squared, just think about, well, do we know 3 squared? And then tack on 2 zeros. So we know 900. And again, if that's really big, right? If you're getting a -32 and do you really want to multiply that? No, maybe not. But can you multiply 4 times 25 or -4 times a -25? Well, that gives you a positive 100, and 100 times 8 is 800. So while they're big, they're still manageable. You can still do it. You can go ahead and add. And before you're like, oh yeah, we're done. Well, what do you know about the square root of 1700? Well, can we simplify that a little bit? Well, really, this is 17 times what number? 100, right? What's the square root of 100? 10 times the square root of 17. Plus or minus 10 square root 17 over 16. What do all of these have in common? Well, they all have a 2 in common. So this is 15 plus or minus 5 square root 17 all over 8. Now you do have your 2 solutions here, right? But we only have room for how many solutions? We only have room for 1, so that means one of them is not necessary. So t is equal to 15 plus 5 root 17 over 8, or 15 -5 root 17. Now, which one is not necessary? Well, think about t, right? What does t stand for? T stands for time. So which one will provide you with negative time? This one. So we do not need that one. And again, I do not have, we do not use a calculator in our class. So we would just be leaving it as an exact solution. On your homework, be on the lookout. It might ask you for rounding to 2 or 3, what's that, 2 or 3 decimal places. So just be on the lookout for your homework. It's very clear in those directions. Now let's talk about, and this is the last thing we're going to do, I promise. Let's talk about the metric system. So on your homework, you might come into contact where it's not feet per feet per second. Yeah, feet per second. It's going to be meters per second. So we're just going to swap. So if in meters per second, we are going to swap the -16 for just a -4.9. The rest of the problem is the exact same. The only difference is just we're working with different units of measure. So we're going to swap your -16 for a negative 4.9. Most likely on your homework, you're going to have to be using a calculator, but keep in mind on the test, we are not allowed a calculator. So this is probably the biggest one you might see. Sometimes I do give it to you where it's a little bit more factoring manageable. So just be aware.